Welcome to Physics with Mr. Brazil. This is part 4 of a 4-part series, and we're going to use information from part 1 and part 2. So if you haven't seen those, you can go back, or you can just go along with what I'm about to give you. So we have a ramp, and it has an angle theta, a box that's being held up about 5 meters up the ramp. Okay. And this box is going to slide down. And in part 3, we determine the velocity that it would end up at the bottom of the ramp. What if it were to slide on a horizontal plane? And can we determine the distance it will travel? Well, let's take some information from those 2 videos. First of all, the angle is 25 degrees, and that's going to be necessary. That's going to determine our transition into a horizontal component. I'm going to keep the coefficient of friction the same so that we don't have to use any other forces. So in other words, when the box transitions to the horizontal plane, there's no change in kinetic energy or no change in kinetic energy or forces, just that there's a change in direction. So we're going to take that into account. Okay? And what else do we need? Well, we need also our acceleration down the box, which was A parallel, 3.9 meters per second squared. That was from our part 2. And part 3, we determined the final velocity. I'm going to call it final velocity parallel at the bottom of the ramp was 6.2 meters per second. So that came from part 3. Well, since this box is transitioning right here at the bottom, it's changing direction, so we're going to have to take that into account. We mentioned earlier, or I mentioned earlier, that we're not going to look at the energy, that it would just no energy change, just a change in direction, just for the moment, to make this pretty straightforward. Well, we're going to end up using our equations of motions. V final squared equals V initial squared plus 2a, so a is in the horizontal component, times delta x, and we're going to try to determine delta x. Well, here's what's important. That box is going to stop at some point, delta x, so that means that final velocity in the horizontal direction is going to be equal to 0. Now, what is a and what is x? Well, a is going to be equal to the acceleration in the parallel direction times cosine theta. Now I'm going to use 25 degrees, but theta can also be equal so that you can get the negative component, meaning it's a deceleration. 180 minus 25 degrees, and that will work. The final velocity, or the initial velocity, is going to be equal to the final velocity parallel times cosine theta, because there is a change in direction and we want to take these into account. So doing a little algebra and rearrangement, you're going to determine that V initial squared equals 2a delta x. Therefore, delta x, the distance that the box will travel, will be negative V initial divided by, 2a delta, not delta x, that needs to be erased. Let me erase that. That was a slip of the mind. Okay, let's go back. Okay, over 2a. Well, let's put in our values. Negative, make sure you put parentheses, because this is going to be a whole different thing here, this negative. So I'm going to put 6.2 meters per second times cosine 25 degrees. Okay. And then I'm going to do 2 times 3.9. And since this is, I'm going to put the negative because is a deceleration, cosine 25 degrees. Again, I could use 155 and it would have been fine. When I do the math for this, the box will stop approximately 4.5 meters. Okay, so this is just giving you a basic introduction into determining distance from an inclined plane. Enjoy doing physics and keep practicing. Thank you.